Hello everyone and welcome back. In this lesson, we will be classifying the roots of a quadratic equation, and we want to do that using the discriminant. In this video, therefore, you will learn about the discriminant, what it is, and how to use that discriminant to classify the roots of a quadratic equation. First up, what is the discriminant? In the quadratic formula, this section, b squared minus 4ac, is what we call the discriminant. And the discriminant is that part of the quadratic formula that gives us information about the roots of the quadratic equation. That is, the value, the number that you get when you work this part out of the discriminant can tell us if the roots are one of three things. It can tell us if the roots are real and distinct, if they are real and equal, or if they are complex. So let's look at each of those three cases. The first case here, it says if b squared minus 4ac is equal to 0, that is, if your discriminant is 0, then the roots of the equation are real and equal. That is, when you work it out, you're going to get the same number for both roots. Let's write down the discriminant. B squared minus 4ac, and let's substitute. A is 1, B is 4, and C is 4. So we have 4 squared minus 4 times 1 times 4, which gives us 16 minus 16, which is 0. So b squared minus 4ac, the discriminant is 0. What does that mean for the roots? It's saying that the roots will be real and equal. That is numbers that we use all the time, real numbers, and equal to each other. So let's try to solve this equation and see what happens. Plugging it into the formula, we have x equal to minus b, which is minus 4 in this case, plus or minus the square root of 4 squared minus 4 times 1 times 4. That's the discriminant. And we put that over 2 times a, which is 2 times 1. Now this gives us negative 4 plus or minus the square root of, as we saw there, 0 over 2. So we have x is equal to negative 4 over 2, which gives us negative 2. Now remember, in solving a quadratic equation, you are supposed to get 2 roots. Now here, the question is telling us that we have only 1. But the discriminant is also telling us that it's actually not 1 root, but 1 root repeated. And so what we actually have is a repeated root. It's a repeated root. So the roots will be real. It's actually 2 numbers, negative 2, negative 2. But because it's repeated, it only pops up in the solution 1 time. So that's our first case. Let's look at another case. When the roots are real and distinct. That is, they are real and they are different. Now, b squared minus 4ac, let's write it down again. A is 1, B is negative 5, and C is 4. Plugging them in tells us that negative 5 squared minus 4 times 1 times 4 would give us 25 minus 16, which is equal to 9. So 9 is greater than 0. So now the discriminant is telling us that because the value here is greater than 0, our roots are going to be real and distinct. That is, they're going to be real numbers and different from each other. So let's try to solve it here. X is equal to minus b, which is minus negative 5, plus minus root of negative 5 squared minus 4 times 1 times 4. Go through it very quickly. 2 times 1. So we have 5 plus or minus the square root of 9 over 2. And we know the square root of 9, it's 3. So we have here 5 plus or minus 3 over 2, which gives us 2 answers. 5 plus 3 is 8 over 2, which gives us 4. 5 minus 3 is 2 over 2, which gives us 1. So notice that our numbers 4 and 1 are real and they are different from each other, or they are distinct. So we could, without actually going through and solving the equation, it's telling us that because the discriminant is positive, greater than 0, then our roots are real and distinct. Now let's look at our third case. If the discriminant is negative, then the roots are complex. What does complex mean? Let's talk about that a little bit. If we have, for example, this equation, x squared plus 1 equal 0, then we need to find a number that when we put it here and evaluate it and add it to 1, we get 0. It's a very difficult thing. So trying that, nothing is working. You can put 1 squared plus 1 give you 2. Obviously, if you put 0 squared plus 1 is 1, and that's not 0. So let's try to solve it. X squared will be equal to 0 minus 1, and so x squared is equal to minus 1. And therefore, finding the square root, we realize on our calculators that we cannot get an answer for this thing. So if you plug it into your calculator, you cannot get an answer. Now the square root of 1 is 1, but the square root of negative 1 doesn't have any real answers. And so in mathematics, we designate the square root of negative 1 to be this letter I. I'm writing I squared. I should write I. And I there means imaginary. And this forms the basis of what we call complex numbers or imaginary numbers. It's a step above real numbers. So the root of negative 1 would give you not a number, but a letter I. And we have I squared, therefore, is equal to negative 1. Now, this is what happens when you try to find the root of a negative. Your calculator will not give you an answer because there are no real answers for it. And your calculator will be trying to work out a real answer. So what we mean by complex numbers is this, that there's no number that you could actually put here to make it work. To get an answer for it would mean that you have to go into a different number system, and that is complex numbers. So b squared minus 4ac in this, let's say a is equal to 2, b is equal to 1, c is equal to 3. So b squared minus 4ac is going to give us 1 squared minus 4 times 2 times 3, which is giving us 1 minus 4 2 is 8, 3 8 is 24. And so we're going to get negative 23. And negative 23 is less than 0. So we're saying if the discriminant is less than 0, then the roots are going to be complex numbers. All right, so let's try to solve it. Negative b, that's negative 1, plus or minus the root of 2 squared. Not 2 squared, 1 squared. Minus 4 times 2 times 3. And we put all of that over 2 times 2. So we end up with negative 1 plus or minus the square root of negative 23 over 4. And so this equation, because we end up here, it doesn't mean that it doesn't have any answers. It's just that if we try to put negative 23 in our calculator, we're going to get error. But to get an answer for this, we have to come out of the real number system and move into complex numbers. So this type of equation, if b squared minus 4ac, if our discriminant is less than 0, then we have complex roots. And pretty much that's what the discriminant does. It tells us about the type of roots that we're going to get before we work the equation out, and we can use that information to do other things as well. So 3 cases. 1, if the discriminant is 0, the roots are real and equal. 2, if the discriminant is greater than 0, the roots are real and distinct. And our third case, if the discriminant is less than 0, then the roots are complex. That's how we go about classifying the roots of a quadratic equation using the discriminant. Now that you know, you can go practice and use that information, check out your quadratic equations, and see which would have real roots, imaginary roots, or equal roots. If you haven't subscribed to our channel as yet, please do before you go. Thank you for watching, and thank you for your support.